Welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of orthographic projection of lines. Coming to the problem statement, a line AB 80 mm long has its end A 20 mm above HP and 30 mm in front of VP. It is inclined at 30 degrees to HP and 45 degrees to VP. Draw the projections of the line and find its apparent length and the inclinations. So by looking at the problem statement, we can understand that the given length of the line is the true length, and also the inclinations are the true inclinations with respect to both VP as well as HP. And also they have given us the position of one of the end point of the line AB, which is indicating that the problem is in the first quadrant. So the endpoint A is 20 mm above HP and 30 mm in front of VP. So we shall go to the sketching window and start executing the problem by drawing the XY line. So for that, let us select a line of thickness 0.18 mm and draw the XY line of any arbitrary length, but the angle should be either 0 or 180. And selecting the text from the annotation, let us annotate the line as XY and the reference plane, that is the plane above the XY line is VP where the front view is recorded, and the plane below the XY line is HP where the top view of the line is recorded. So you can just make it out that this line is inclined to both VP and HP. So the condition is we have to assume the line is parallel to one of the reference plane and then draw its apparent views. So first let us locate the endpoint A by drawing the projector lines of 0.13 mm thickness. So at any arbitrary point from the XY line, let us locate the endpoint A in the space. So it is 20 mm above HP. So I get the front view at a distance of 20 mm. And then it is also 30 mm in front of VP. So I get its top view 30 mm in front of VP. So let me annotate this endpoint as A prime and the front view as A prime and the top view as A. And let me proceed by drawing the locus of this endpoints, that is A prime and the locus of A. And let me annotate these lines as locus of A prime and this particular line as locus of A. So now keeping this as the reference, let us draw the true length of the line, which is 80 mm and inclined to the HP at an angle of 45 degrees. So 80 mm is the true length and 45 degrees is the angle of inclinations with respect to the HP. Okay, it is 30 degrees here. So let us change it. The true length is 80 and the inclination with respect to the HP is 30 degrees. In case if this happens, you can just select the line that has been drawn and you can change the type to continuous line. And then we will annotate the other endpoint of this line AB as A prime and B1 prime. So A dash B1 prime or A prime and B1 prime is the the front view of the line AB when it is inclined with respect to the HP at an angle of 45 degrees. So this is the true inclination and the true length of the line, which is 80 mm. So now we will draw the top view of the same line. So from the endpoint A, the true length is 80 mm and the angle of inclination with respect to the VP is minus 45 degrees. So let us annotate this endpoint as B2, which is the top view of the line AB. So AB2 indicates the top view of the line when it is inclined with respect to the VP at an angle of 45 degrees. So these are the true length and the true inclinations. So you can just see that the true length is the same in both the front and as well as the top views. So now let us draw the locus of those two endpoints, that is B1 prime and B2. This is the locus of B1 prime and this is the locus line of B2 prime. So let us annotate this line as locus of B1 dash and this as the locus of B. So with this we have completed the first condition, that is a line at true length 80 mm is drawn in such a way that it is inclined at an angle of 30 degrees with respect to the HP and 45 degrees with respect to the VP. So now let us draw the apparent views of the line, and that can be drawn by following this procedure. So first what I'll do is I will draw the front view of this AB2 by taking the projector from the endpoint B2 and then intersecting it with the locus of A prime. So this point, that is from A dash to B2 dash, will be the front view of this line AB2. So next procedure is I'll go for the arc by center point and then keeping A prime as the first point and B2 as the second point, I'll cut an arc such that it is intersecting the locus of B1 prime. I'll select the line option again. So let me draw the apparent view of this particular line, the front view. So from A prime to the point of intersection of this curve and the locus line. So this is the point of intersection. So this is going to give me the apparent length of the line AB in the top view, sorry, the front view, and then this is the apparent inclination, which is 45 degrees. So let me annotate this point as B prime or B dash, which is the front view of the line AB. So this is the one which is visible to the observer, so it is dark. Okay, now we will follow the same procedure to get the top view of the line AB. So for that we shall follow this step, that is draw the projector line of thickness 0.13 mm from B1 prime and intersect that with the locus of A. It should be a perfect straight line. So this point is the top view of this point, that is B1 dash. So let me annotate this as B1. So AB1 is the top view of this line A dash B1 dash when it is rotated until it becomes parallel to the reference plane, that is XY line. So now we will transfer this B1 to the locus of B2, and that is done by selecting arc by center point, first point, and the second point is the endpoint B1, and then let me cut an arc so that it is intersecting the locus of B2. So what am I doing technically? I am shifting this point B1 onto the locus of B2. And this point of intersection of this locus line and the arc is what is the top view of the endpoint B, correct? So let me select the line option. Ensure it is a continuous line of thickness 0.50. The endpoint A shall intersect with the point of intersection of this arc and the locus line. So I'm getting the point of intersection as you can see here. So this is the top view of the line AB. So go to the smart dimension, measure the apparent length of the line in the HP, and then also the apparent inclination, which is 55 degrees. So this is beta, and this is phi, and this is alpha, and this is theta. So we can go to the smart dimension and also show the location of the endpoint A, which is 30 mm in front of VP and 20 mm above HP. Ensure the annotations are not coincided by any of the dimensioning lines so that it looks neat. Then go for the annotation, select the leader option, select the properties, change the collection of the correct color of the arrow to black, click OK, and then indicate the direction of the projector lines. So I can also validate this problem if it is correct or wrong by drawing the projector from B dash. So if I draw a perpendicular projector from B dash, it should exactly coincide with the top view of the point B. The front view and the top view should coincide for the endpoint that we have drawn, which is indicating that it is correct. So this could be in either direction, either from B to B dash or from B dash to B. So I'll not indicate any arrow mark here because it is bidirectional. So with this, we complete the orthographic projection of the line AB, which is 80 mm long and is inclined at an angle of 30 degrees and 45 degrees with respect to VP and HP. And then we have drawn the apparent view of this particular line AB as AB dash and AB. Thank you all for watching.